Hello everyone. So you may have seen that whenever a cyclist is taking a turn, then they have to bend. Okay, and normally this type of bend is visible if they are doing any racing. Okay, when you are doing it just for leisure, then in that case you may not be that much faster. So it is absolutely fine, whichever way you can take a turn. But if you are taking a turn with a certain speed, then there has to be a certain angle at which you have to bend. What is that angle? That is what we will see in this video. Okay, so in this video we will be mainly discussing, and in simple words we will try to derive that for bending what is the maximum angle which a cyclist should make with the vertical so that the bending is safe. So let us come to this diagram. Now in this diagram you can see that there is a cyclist who is making an angle theta with the vertical. Okay, I hope you can see this angle theta, and that is taken with the vertical. Now what are the forces involved? Let us first discuss the free body diagram. So cyclist will have his or her mass, so that mass is mg downwards. Okay, then there will be a normal reaction. So this reaction is mainly due to the ground because of this point. Okay, so now as per the figure it is quite easily visible that if this angle is theta, then the angle for r will also be theta, and that angle is taken with respect to point G as per the diagram. So the very first thing what we will do over here is we will take the components of vector r. R is a force which is a vector. We'll just take the components. So r cos theta will be vertical, okay, because in the direction of angle the component is cos, while the perpendicular to that will be sine. So as per this diagram, the horizontal component is r sine theta and vertical component is r cos theta. Now as we know that this bending is required if a cyclist is taking a turn. Okay, turn means we can say that it's a circular motion. So since it is a circular motion, there is a force acting on the cyclist towards the center. Okay, and that force is called as centripetal force. As per our diagram, r sine theta is that force. So I'll write my first equation, and that is r sine theta is equal to centripetal force. Now centripetal force is mv square over r, where v is the velocity, r is the radius of that circle. Okay, so we have to just imagine that the cyclist is taking a turn across a circular track which is somewhat like this, whose center is somewhere over here, and there's a radius. Okay, you have to just imagine that. So r sine theta will be equal to mv square over r. Small r is the radius of that circle. Capital R is the reaction force. Don't get confused in that. Another equal and opposite forces are considered vertically. R cos theta is equivalent to mg. I'll write that as well. So r cos theta is equal to mg. Now what are we trying to find over here? There are certain things which we can find. Okay, first thing is definitely we'll try to find the angle at which the person can safely take a turn. Okay, because the angle at which they have to bend so that the turn can be safe. For that we will just divide these two equations. Dividing these two equations will give me r sine theta over r cos theta is equal to mv square over r, and mg will come here. M and m will get cancelled, and r and r will get cancelled. Sine by cos is tan, so we'll get tan theta is equal to v square over rg. From here I will get theta is equal to tan inverse of v square over rg. Now you can see the components which are forming theta. One is velocity, one is radius, g is constant. Okay, so it all depends on with what velocity you are taking a turn and what is the radius of that circle in which you are taking a turn. According to that, the bending angle will be decided. So if you are a racer, if you want to go into bicycle racing or even motorbike racing, then you have to understand these technical facts before bending. Okay, so this is the value of theta, which is the safest bending angle. From here we can also calculate the velocity. What will be the safest velocity with which the person can take a turn? So for that you can just use v square is equal to rg times tan theta, and from here you can get the velocity. Okay, now just imagine that the bending angle is 45 degree. That will be most probably given in the question if they are asking velocity. In that case tan 45 will be 1, and we will get v square is equal to rg, or v is equal to root rg. So these are not the formulas, but you should understand the way we are solving these equations and the way we have written these forces. So primarily, these two equations of vertical and horizontal forces are important, and before that you should know how to draw free body diagram representing all forces. So this was all about bending of a cyclist.